So hello guys, today we will talk about the point-to-point network. Before we start, I would like to introduce to you what is point-to-point network or wireless connection. Basically, it is like a Wi-Fi, but it has a greater distance. It can be kilometers away from the access point to the client. So first is we're gonna talk about the throughput. We did discuss before that the throughput is the speed of the data transfer, and the second one is the latency. So throughput is declared on an Mbps or Mbps or kbps. Basically, it is a megabyte. Megabyte. If you're on fiber or higher internet, it's gigabit per second or G or P. If you are familiar with the memory, megabyte, gigabyte, kilobytes. So latency is declared on milliseconds. For example, 2 ms and 1 ms is the best latency because it's the fastest latency. So before we discuss this both of this word or this topic, we should know how, for example, we have a computer here and we are connected to what we all called internet, or maybe a network or a router. Internet or a router if the network is offline, or intranet, what we call intranet. If the network is offline, it is called intranet. If it is online, it is called internet. So we have a server or another computer here, because a server is also a computer, a specialized computer to serve image or website. Now, every data that we send, for example, we are making an audio call or we are streaming videos here to here, every second it sends a packet of data. Basically, it is 20,000 kilobytes something back and forth. From here, we call it as an upload because we are uploading data to the server. Backport, we call it as a download if we are the client. Download is something that you put data onto your computer from the server or from the network. So we measure this one, the speed of this one. How much data do we transfer from client to server and backport? We call this as a throughput. How about the time to travel? The time to travel the data from this client to the server and back to the client. We call this latency. Millisecond. There is 1,000 of millisecond in 1 second. If you are familiar with measurement, a standard US measurement, milli, micro, the next thing is milli times 3 raised to 3 and micro raised to 6, something like that. And above that is kilo, mega, and etc. So that's it. That is basically it. Throughput is the maximum data that we can transfer per second. So here, if let's say we have a 30 Mbps, so here we can say that the network connection can transfer at 30 megabyte to every 1 second. So it's pretty fast. Now, how about the latency? Sometimes the throughput is higher, sometimes the latency is higher. We need this before we start the personal zone because this two word is affected by personal zone. So latency, the time it get or the time it takes to send data from the server back to the client. So that's it. Ping is very important. Also, throughput is very important. Both of it is important because you need a high data transmission rate. You need a high latency. The lower you need lower latency means good. Higher throughput is good. So it is indirectly proportional. For example, we have here access point, and for example, we have a distance of 10 kilometers. Yes, maybe you would ask, is it really possible to host Wi-Fi connection to kilometers away? Yes, it is possible with the use of a point-to-point device. If you like to browse about the different brands that I've been exposed to and the exact model, you can just go down on the description below. So, for example, to continue, this is the access point. For example, we can call this the point A. So here we have the client point. So we can call this as point B. Now, it is possible to pass an internet connection or a wireless network. For example, you have to pass an IP camera from 10 kilometers away from access point. Access point is the one that is transmitting signal to the client. I'm sorry, to the client. So the client is only the receiver. This device is only receiving data transmission from the access point. Think of it as this like a Wi-Fi router, and this is the cell phone. That is the simplest example. But to be able to have a better connection, for example, in our house, if our Wi-Fi device is placed here and our cell phone, we are using cell phone from the other side of the house, of course there is a delay or a decrease in speed of the internet. So why did I say this? Because we will also talk about Fresnel zone. Now, what is Fresnel zone? Fresnel zone is basically an angular direction from point A to point B. So it has an upper Fresnel zone, and it has also a lower Fresnel zone. Horizontally, it has also a Fresnel zone depending on the device. Some device has elongated Fresnel zone. Some device has an ovular. Some device has this horizontally has a Fresnel zone of an ovular. Some device has only elongated. So think of it as, for example, here is the AP and here is the client. Here is the AP and here is the client, for example. This device, we call this DA and device B. Now this device can, access point can transmit a wider range of area. So you can put a client here, for example, this is 10 kilometers. You can put client here, but it is a different topic, multi-client point-to-point network. But here on the elongated device, you can only put a client within the range of the signal. So this is the disadvantage of this device and the advantage of this device. But this has a higher speed because the signal is focused on one direction. While this device, the disadvantage is that it has a lower transmission power because this device should be able to transmit signal within a wide range of area. So going back on to the Fresnel zone. So when we talk about Fresnel zone, that's the object that is involved is an antenna. Why? Because, for example, this is the ground. Because to be able to transmit the data fully, we should eliminate any object that is interfering within this area, the Fresnel zone. Because any object interferes, a tree, a house, a building, can decrease the speed of the P2P, the speed of the end, especially if there is a mountain that is surpassing the line of sight. That is a very big problem when we talk about the Fresnel zone. Because P2P really required the line of sight, this one. Point-to-point connection really required this one. The line of sight should not have any interference to be able for the device to communicate properly. That is the second things to know. First is that any interference within the Fresnel zone can affect the speed but have a data transmission. But sometimes fully, if a mountain or a building is surpassing the line of sight, it can even cut or kill the connection. There will be no signal. But sometimes, if the obstacle is just small, it's okay. It can even transmit a signal, but with a much significant decrease on the signal.
Thank you for watching. If you like this video, click subscribe. More to come. Click here to play this video.